Hi, Mr. Pepperell here, and today I am thinking about the relationship between energy and potential difference. So hopefully by the end of this video you should know a bit more about what energy transfers take place when charge flows through a resistor and how the energy transferred by a flow of charge is related to the potential difference.
So we've previously talked about resistors opposing the flow of current in electrical circuits, but let's just remind ourselves why this actually happens. Well, electrons that are flowing through the circuit, made to do so by the battery, okay, they're working their way through the resistor, and as they are working their way through the resistor, what they actually do is collide with the atoms, actually these metal ions that make up the resistor. And when this happens, what those electrons actually do is transfer some energy. Okay, so we've got the electrons working their way through the resistor. We've got the resistor made out of these metal ions. But what actually happens is the kinetic energy, which is in the electrons, when the electrons come through and they collide with a metal ion like this one here, what actually happens is that kinetic energy is transferred to the metal ion. Okay, and when the energy has been transferred to the ion starts to vibrate a little bit more, and the more energy transferred to it, the more it starts to vibrate. Okay, so the more electrons that bang into it, the more energy is transferred, and the more this ion starts to vibrate about, and the more it vibrates, the hotter the resistor becomes. Okay, so we can actually summarize this little bit of knowledge here by saying that when charge flows through a resistor, the energy is transferred to the resistor and it becomes hotter. Okay, now let me just say that this little bit of content that I'm going to talk about will only feature on the higher tier paper, so if you find this a little bit more challenging, that's why basically. Okay, well, thinking about resistance, transfer and energy, okay, the amount of energy that actually transfers to a resistor in a certain time depends on a couple of things. Firstly, it depends on the amount of charge that passes through the resistor, and secondly, it depends on the potential difference across that resistor. And these two factors that we're just talking about here are related by a little bit of maths. So let's just see how we can actually get to the equation that links these two factors that affect the amount of energy that's transferred to a resistor. So way back a lot earlier in P2, when we were looking at work and energy, momentum and that sort of thing, we found out there was a way of calculating energy, okay, and we found this equation: energy equals power multiplied by time. Well, in P2 5.4, which was the last lesson basically, we also found out that we've got a way of calculating power. This is the thing that we looked at last lesson. We found out we can calculate power if we know the potential difference and the current. We can multiply those together to work out power. So basically I could rewrite this equation that I've got here to include those values of potential difference and current. Okay, what I could do is rewrite that equation as this: energy equals potential difference multiplied by current multiplied by time, because potential difference multiplied by current is actually how I work out power. So you can see those two equations basically say the same thing. I've just extended this power bit to write the whole thing out there. Okay, within this equation though, we've also got something else. Okay, we've also got current multiplied by time. Now current multiplied by time is something we've met before, because that is the way that we actually calculate charge. So again, this gives me another way of rewriting my original equation. If I look here, what I can actually do is use my current multiplied by time to give me the charge there, and I can rewrite my original equation here as energy equals potential difference multiplied by charge. This equation is basically exactly the same as this. I've just included different ways of calculating the different bits within the equation. Okay, now we can see here though, energy equals potential difference times charge. These are the two factors that I said affected energy transfer originally. Okay, and you can see that if I change one, the potential difference or the charge, or if I change both of them, even if I change both these values, it would indeed affect the amount of energy that was transferred. And as I said, right, this is higher tier content. You don't need to worry about how I rearrange this equation and to get this one and then rearrange it to get this one here. You're not going to be asked to rearrange those equations yourself in the exam like I did, but you must be able to use that final equation. And of course you need to remember here that the energy is measured in joules, the potential difference is measured in volts, and the charge is measured in coulombs. You just need to be able to use that equation. So let's have a go at doing that. Okay, my problem says at the top here, it says calculate the energy transferred when a charge flow is 30 coulombs and the potential difference is 4 volts. So what am I going to do? Firstly, I'm going to write out the equation I'm going to use, the one we just talked about. Energy equals potential difference multiplied by charge. Remember, in an equation, charge is given by the letter Q, just to confuse you. Okay, then what I'm going to do is substitute in the values I've got. So I need a charge value here. I've got 30 coulombs. I need a voltage. I got 4 volts there. Okay, so I'm going to substitute those values into my equation. So that gives me energy equals 4 volts multiplied by 30 coulombs. And the last thing I need to do is just solve the equation. So I can see that my energy equals 120 joules, joules being the unit of energy.
So that is everything we need to know about energy and potential difference. Any problems with that at all, don't hesitate to tweet me at Mr_Pepperell or email me and I'll get back to you ASAP. Thanks for stopping by.